I can recollect, remind me of if I'm going on. I completed with, we have completed with due to rain.
Yes.
Completed with rain, we use the term which is being marked as a magnetic moment. Which was marked by us as magnetic moment. I told you that time to come, we'll be dealing more on it. We'll be delving more about what magnetic moment exact is. So what magnetic moment in exact is product of current and area. Area towards the vector quantities, so is magnetic moment. Magnetic moment is a vector quantity. How we decide direction of vector, how we decide direction of magnetic moment vector? By curling our finger in the sense of current flow. In whichever sense the current is flowing, we'll curl our finger in that sense, right hand. We'll curl our finger in that sense. Whichever direction thumb will point will be accorded direction to magnetic moment vector. Clear, dear?
Yes, sir.
Goes without saying, will be perpendicular to the plane in which current is flowing. Will be perpendicular to the plane in which current is established. Right, dear? Perpendicular can be away, perpendicular can be towards. That is subject to sense of flow. It's subject to sense of flow. If it is this way, it's outward. If it is this way, it is inwards. Why I'm into much on dwell, owing to fact that it is being getting of late getting good weightage vis-a-vis ITJ mains. Quite good weightage vis-a-vis ITJ mains. What they do, they ask on magnetic moment. For instance, given a rod, there's a rod of certain length given to you. Length of the rod is L, let us say, and lambda is charge per unit length. You are to find magnetic moment associated with this rod when it is rotated with angular speed omega. It is rotated with angular speed omega. What I seek magnetic moment. What is magnetic moment for this rod? What are we to assign magnetic moment for this rod? Rod rotated with an angular speed omega and is rotated about one of its ends. One of its ends. Got in there?
Yes, so there's
Tell
no
me, how should I go about it?
current flowing through the rod.
Yeah, there's current flowing through rod is not gotten to us.
So
There is no current flowing through rod.
without the motion of charges, how do we associate a magnetic field with this?
Told you that omega is associated with rod. Rod is being rotated with omega. Lambda is charge per unit length and
Oh,
rotated with
rotated.
omega
Yes, yes,
will get current flow. And that current flow you are to decide.
yes, sir. I missed out on the lambda part.
To decide on the flow of current, what to do, how to decide on flow of current. Flow of current you are aware of will be charge divided by time taken for the same, right, dear?
Yes, sir.
So we can take charge, but to take charge, you'll have to assign some length to it.
Yes, sir.
You cannot take all the charge in one go. Tell me why. Why can't we take entire of the charge with the rod associated is charge per unit length multiplied with length will get me total charge.
Yes, sir.
But that doesn't augur well when I'm asking about magnetic moment. Could you please let me know why can't I go with the length in totality?
So each one of those
Why?
charges are at a
Yeah.
different distance and hence moving at a different velocity, hence generating different current.
One much that to effect. If I say I'm to calculate current, current will remain same. Current will not change, Vasudev. Even if the distance is different, current will remain same. Tell me why? Because same amount of charge will pass in unit interval of time. One rotation, time taken will remain. Correct? Yeah.
Yes, I was saying if we assume like a thin wire that's wires which are concentric circles. So if
Correct. Correct.
and then the charge, there'll be same amount of charge, but it'll be taking longer to complete. I mean, wait, actually, you have a
Taking longer to complete. That is not my
yeah,
concern.
yeah, okay, no, wait, right, yeah,
Getting
perhaps,
it?
yes, I don't know,
Getting
perhaps,
it longer distance to complete. Time remains.
yes,
Correct? Yeah.
time remains the same.
To encapsulate longer area, you can say,
Mm-hmm.
larger area to be precise. And there is where my concern lies. I have to calculate product of current with area. I don't have any issue with current. Current remains. I have issue with area. Area will appreciate as I move further. Correct, Vasudev?
Yes, sir.
And I have to find product of current and area. I have to take specific distance. Different distance will encapsulate different area. Correct, dear?
Yes.
Which is to make imperative on us to assign certain distance to an element. What I do, I take an element over here, small element of what length dx, at what distance, at distance x. This is to envelop what area we are aware of. This will envelop an area pi x square. This area has got some current to its merit. What current to its merit? Current which is housed by length dx. What current is housed by length dx will depend on what charge we are associating to it. We are associating lambda dx charge to the length dx, correct? Okay, what charge flows through an area which I am to show now, area of my palm? What charge flows through this area in certain time, in one rotation? This is the charge which flows through my area, palm area, in one time interval. By one time interval, what I mean, time taken to rotate once. Correct, dear? And what
Yes.
that time is to me, that time is to me, tau, let us say, what is tau to me? Tau, we can write in terms of omega. Let me write first in terms of omega. 1 by tau is nothing but frequency, correct, dear?
Yes, sir.
So what is this to shape to is lambda dx into frequency, into frequency. Do check please. Lambda dx into frequency. 1 by tau will nothing be but frequency. Though I wish write in terms of omega. You're aware of t is nothing but 2 pi by omega. Correct, dear?
Yes, sir.
T is nothing but 2 pi by omega. What can we do over here? We can substitute either T or F. What will be omega? What will be omega? Known to us, 2 pi F. So what will be F? Omega by 2 pi, correct? What then we get to see? Lambda dx into omega by 2 pi. This is what to me? This is current to me. We write di for it. Why di? Current associated with small length. When that small length is made to move, rotate, right? Okay. Now, small amount of mu then that we can associate. Mu will be current, which is lambda dx omega by 2 pi. This is current multiplied with pi x square, right?
Yes, sir.
Magnitude of mu, correct? I into area. For total mu, integration is what is sorted. From where to where? From x is equal to 0 to x is equal to L. Please do check. Get me the answer. Give me the answer post check. You can get me in terms of lambda, no comms.
Lambda L cube omega by 6.
Lambda L cube by 6, is it?
Lambda L cube omega by 6.
Okay. Got it. Tell me what will be mu if it is rotated about its center. Get me mu, please. Its magnetic moment subject to it being rotated about its center. Rod of length L rotated with angular speed omega, this time about its center. What is the only factor out here to change?
So
So
perhaps
we can go with in the same x dx, this time the reference being center right here.
the limits will change from minus L by 2 to plus L.
Limits are to change from where to where?
Negative L by 2 to plus L by 2.
From minus of L by 2 to plus of L by 2, right dear?
Yes.
What will that get me? What will be the answer? Let me know of the answer. These are the mundane periodic questions. These are of greater import vis-a-vis everyday kind of examination. Small time examinations. Minus of L by 2 to plus of L by 2. Limits are to change. Mu to be gotten. That mu will be associated with. That mu will be associated with.
So, okay. The same answer as before, 6 is replaced with 24.
Subject to rod being rotated about which point? As you can see for yourself, answers are to differ. Correct, yeah?
Yes, sir.
What this time?
So, lambda omega L cube by 24.
Lambda omega L cube by 24. That is what we get over here. Just to reinforce one more question, and that question we have to relate with what we have studied in gravitation in order to get one short answer to it. I wish find angular rhythm. A sphere is rotated with angular speed omega. A sphere is rotated with angular speed omega with a surface charge density sigma on it. With a surface charge density sigma on it. Fine. Vasudeva, you keep on the recording?
Yes, sir, it is.
With the surface charge density sigma on it. Find magnetic moment associated with the shell. Find magnetic moment associated with the shell.
Isn't this similar to the questions you asked me when we were beginning this section? You said there was a disk with a uniform charge density rotating, and it wouldn't have any magnetic field associated with it since the charge configuration isn't changing. Could we?
I said will not be associated with it
because the charge configuration isn't changing. It's a uniformly charged disk.
Electric field. That was electric field. Electric field is not to change, right?
Yes, sir.
Not in odds with magnetic field may also remain. But my point of consideration over here is not magnetic field. It is magnetic moment.
Yes, sir, but like I just wanted to ask, can we say that this configuration will have no magnetic field associated with it?
No magnetic field associated.
Yes, sir, because the charge configuration isn't visibly changing from the outside when you
How are you
observe it.
coming to that conclusion? How did you draw that conclusion? Yes, please.
Because the charge isn't exactly moving. I mean, even if it is, it's being replaced by charge exactly in the same position. So, I mean, there's no visible motion of charge.
When I presented disk, right, I told you that electric field will remain, correct?
Yes, sir.
Now let us take that disk and try to find magnetic effect due to charge on it. Rotating, we can get myriads of rings, right, Vasudev?
Yes, sir.
Each ring will have its effect, correct?
Okay.
Each ring will differ from the other on radius, correct?
Yes, sir.
Each ring will produce magnetic field on the axial point, correct?
Yes, sir. But like,
Okay. Those being same in direction can also be added, correct?
so you're saying having a static ring and running a current through it is equivalent to having a uniformly charged ring and rotating it.
I'm saying that when you're having a disk, whatever electric field you are getting, when it's not rotated, when it's not set to rotate, and when it's set to rotate, they are immune to each other. They are same. They don't change.
So, but the magnetic field is introduced when the disk is rotating.
Magnetic field will be introduced when you're rotating the disk.
Yes, sir.
There'll be no magnetic field when the disk is not set to rotate. But when rotating, you are according current to it, correct?
Yes, sir.
So that is to produce magnetic field. Again, this magnetic field won't change. This magnetic field will remain. It won't change. Getting it here?
Yes, sir.
Okay. Now, what will that be is what I have asked. Taken sphere or hollow sphere to be precise, shell to be precise is what we technically call being rotated about one of its axis or diameter. Right here, we are rotating it about one of its diameter. Find here.
Yes, sir.
What will it be? A difficult task. Why will it be a difficult task? You're aware of what you'll have to do, right there. You'll have to cut it into rings, isn't it?
Yes, sir.
We'll have to cut it into rings. With every ring, I'm to associate magnetic moment. Eventually, we are to go for the addition, scalar addition, I would say. Why? Because they are all to get you magnetic moment in same direction. Right here.
Yes, sir.
We'll have to go for a scalar addition, though it requires quite tedious calculation, taxing on us. What to do? And that was not the purpose. You're aware of what to do, you'll be able to be through it. What to do? Cut it into rings, find charge on every ring. That charge will get you what current you can get easily right here.
Yes, sir.
And then use the formula that we have derived, mu naught 4 pi twice mu by dq, add them all by integrating, correct?
Yes, sir.
We'll do that as well, no issues. What I wanted to bring over here as a point of interest, something which I'm going to take a leaf out of, and that being gravitation. You're aware of gravitation, you're aware of what is area swept by a planet with sun taken as center. What is the time rate of area that a planet, let's say Earth, can sweep? What is the rate with which that area will be swept with sun taken as center? So what I'm referring to, dA by dt. I'm referring to dA by dt, where dA is the area swept by Earth, sun being at center, divided by dt, dt being the time taken by it. So dA by dt, what is dA by dt to get me? Taking some liberty on the orbit, we are aware of that it is elliptical in nature, and we can establish whatever I'm going to establish. We can establish in exact the same with elliptical path, but taking liberties, I am to first see for circular. So let us see first circular. For circular, for circular path, what be area swept, sun being at the center, by Earth in time dt will depend on angle negotiated in time dt, correct? Will depend on angle negotiated in time dt. Let us say in certain time, what that time? Tau. In tau, what area is swept? Pi r square, correct? So pi r square swept in what time? Tau. D theta. D theta means what area? Should be known to you, isn't it?
Yes, sir.
Because area is pi r square owing to a formula, by the way. We take small terms and accordingly get. What will be this? When the angle is 2 pi, area is pi r square, correct?
Yes, sir.
When the angle is 2 pi, then the area is pi r square. When the angle is d theta, mind you, d theta should be in radians, as 2 pi is in radian. So when the angle is d theta in radian, then what area we are to negotiate or will be able to establish, will be able to claim is pi r square 2 pi into d theta. Correct, dear?
Yes, sir.
What will that area be? R square by 2d theta. Find here.
Yes, sir.
That is the area. And that area is swept in what time? Let us say dt time. So what is the rate of area being swept? Rate of area being swept is termed as r square by 2 d theta by dt. And d theta by dt is nothing but omega to us. Correct, dear?
Yes, sir.
What we then get to see is r square omega by 2. What is this to us? This is the rate at which area is swept. Please do check, class. This is the rate. I have divided by dt, taken dt into consideration, writing omega for it. This is the rate with which area is swept.
Yes, sir.
We generally mark it as dA by dt, rate with which area is swept. dA by dt is what to us? R square omega by 2. There's a customary to write it in terms of angular momentum. Okay? Customary to write it in terms of angular momentum. Let us take mass of Earth as m. What will be angular momentum associated with it, assuming it to be a point mass?
mr square
Why
omega.
point? How? Yeah, we know that. Why point? It's distant. So we can assume it to be a point. What do we then associate with it? Is mr square omega, correct? I into omega. Can we say that?
Yes, sir.
What then this term can be marked is, tell me, can we say L by 2m?
Yes, sir.
Because L is what to us? Mr square omega. L is mr square omega, where m is mass of Earth here. dA by dt is what to us? L by 2m. Please take a good note of it. That's the reason we did go in some jogging of memory. Jogging of memory owing to what we are to get from it. What we is this is to get me a takeaway. So what we are to get from it is a takeaway. What is it to get me is an important takeaway. What is that to me? I will relate current. I will relate current over here, taking the same element as mass there. As mass is property, so we know is charge. Correct, dear?
Yes, sir.
So what I do over here is replace M by Q. Bring it to left of the equality. Bring it to left of the equality. Okay, dear? So bringing charge to left of the equality, or I ask you, what in general is charge? How do we represent charge when we have to represent in terms of current? You say it is I dt, correct? How do we represent charge? I dt. Let's do the same. L Q I D, sorry, L2 I dt, correct? Is what to us? dA by dt. dt and dt gone.
So I think I missed a sentence of yours. How did you get L by 2m is equal to L by 2q?
Q is equal to I dt 2q 2m. That's the reason I am simply replacing mass by charge, both being property. So I am doing it. A replacement is being over here sorted. Why? Because I wanted to relate to what you'll be getting when you go into the organic mathematical calculation of magnetic moment. Okay? I'm trying to draw a Q over here. I'm associating charge to mass. Why? Because they are property. They are property. On property term, they are unison. Okay? That's the reason, Vasudev. I know I'll have to prove what I have shown over here. I'm just drawing parallel with this equation
Yes, sir.
so that it is easy to commit to memory, nothing much. Okay?
Yes, sir.
Okay. Now tell me, please, what do we have then over here? What do we get from here? Anything which is much for us to reckon in terms of L. What is L? L, I ask, for sphere that we have taken. What will be L for sphere? Are you aware of what is L for sphere? We are aware of what is L for sphere. Wherever is asked mu, I can use L for sphere. I'll be using L for sphere, mind you. Why? Because the picture or the object into consideration is sphere. So L of what will be used over here? L of sphere will be used. Q on what will be used over here? Q on sphere will be used. Find here.
Yes, but I'm still not able to understand how you related the magnetic moment of a sphere to a planet revolving around a star. I mean, how are these things even remotely related?
Okay, okay. In that case, what I'll ask you to do is to go for the organic calculation of sphere. Okay?
Yes.
And then let's see what answer we are getting. What is the answer to it? I told you I'm trying to draw a parallel so that it is convenient for me to commit to memory. If I lose on it, I'll be able to recollect by using dA by dt is equal to L by 2m.
Yes.
I'm no odds with dA by dt is equal to L by 2m. I'm using it over here without setting an analogy because there is nothing related to a planetary motion and a sphere rotating about its own axis. Fine, yeah?
This is more of a memorization trick.
More of a situation wherein we relate mu with P. Okay, as we write mu cross B, mu dot B, knowing that mu has got nothing to do, magnetic moment has got nothing to do with dipole moment. Fine, yeah? They are different physical term altogether. Okay.
Yes.
So this was just to commit to memory. Wanted to present it in this form. What I'll do, I'll go for the organic calculation. Fine, and then I'll get back to it. Okay.
Yes, sir.
So there is a shell given to me. What I want to know or what we seek is to get magnetic. So how we do? How we realize magnetic moment? For the timing, I'm erasing it. Okay.
Yes, sir.
So how do we realize magnetic moment for a sphere, for a shell? What we do is what I am to do next. What we in general do is what I am to do next. The shell taken by us, we take ring. Ring taken. We take a ring. Ring of certain radius. What will that radius be? Of course, theta is what it is to depend on. R is the radius of shell. What will be radius of ring? According to theta that I have taken, I'll get it as R sine theta, right dear?
Yes, sir.
Okay. What about area where charge resides? Charges reside on the periphery. So what area we have to associate with it? 2 pi r sine theta, the length, multiplied with, as we are coming from our understanding vis-a-vis, I think you must not have lost on, how did we calculate moment of inertia or center of mass, right? What did we take? Wherever mass is located. Accordingly here, wherever charge is housed. So charge is housed on the periphery. What do we write for length then? Length is 2 pi r sine theta, thickness r d theta, correct?
Yes, sir.
Multiply with sigma will get me charge on it. Multiply with sigma will get me charge on it. Multiplied with omega divided by 2 pi will get me current that it can claim, right dear?
Yes, sir.
Okay, because omega by 2 pi is nothing but frequency. This is the current it will claim. What about d mu, small amount of mu? We are aware of small amount of mu is nothing but current multiplied with area. What is area over here? Pi r sine theta whole square, right?
Yes, sir.
Replacing for current as what we got above, 2 pi r square sine theta, okay, pi r sine theta into the theta. Got it here?
Yes, sir.
Okay. 2 pi r cube, pi square r cube, sine square theta d theta, right?
Yes, sir.
Calculate basic integration. Integration from where to where? To take all the ring that go in, form it. To go that go in, shape it. Where to where theta should vary. Theta will vary from 0 to
Pi.
pi. Please go for integration dear. Sigma, I'll have to write. I write it over here. Sigma. Sigma. Sigma.
So I think you also missed an omega by 2 pi everywhere.
Have missed omega by 2 pi as well? Yes, we have, rightly so. Thank you for reminding me omega by 2 pi. Omega by 2 pi, that will help me get rid of 2 pi and omega. So 2 pi gone, omega remains. Okay. Pi r cube sigma omega sine square theta d theta. Integration sorted, please.
So it was pi r sine theta whole squared. You seem to have missed.
Yes.
You seem to have missed that too.
Okay, where shall I place them? Pi. Pi here, right?
No, so the 2 pi r sine 2 pi r squared sine theta came from the I. This one is the next term, the next factor. Pi r sine
Yeah,
theta.
there is one more pi over here, right? Pi square, correct?
No, so you've
One
already
is
written it next to that, the next factor, the next in the next
correct,
parentheses.
correct. Square missed here, right? So I think we'll have to incorporate it. Where shall I incorporate it? Yeah. R4 will get sine square and will get 1 pi square, right?
Yes, sir. Pi squared, so it'll
So
be,
that'll be R4. This will be R4, right?
yes, 4 sine cubed pi
4
pi 3 and pi cubed.
sine cube and pi 3. So a pi remains, right?
Yes, sir.
Okay, R cube, R4. This is 4. And this is easier for us to integrate because we can assume sine theta as z. Check it out better.
So even if you do assume sine theta is z, it doesn't simplify the problem in any manner.
Is it? It will.
So this is sine theta is z.
How will it?
Sir?
It should be. Change 1 to 1 minus cos square theta and sine theta d theta. It will certainly help you a lot. Sine square can be changed to 1 minus cos square theta, dear. And 1 sine theta is to remain, correct?
Yes, sir.
That'll help us, right?
Perhaps.
Check it out.
D theta.
That is the process we use for cos q theta, sine q theta integration, by the way. Mathematics, right?
Yes.
Theta can be marked as 1 minus cos square theta into sine theta d theta. What we can do? 1 minus z. What should we do? Tell me. Shall I take that z? Okay.
So if you take
Cos 1 minus z square, right?
yes, sir. So that would make more sense.
D tan cos theta
dz is equal to minus sine theta d theta.
of sine theta d theta, correct?
Yes, sir. So
This can be marked as minus of dz. This is to integrate it now. So minus of z and plus of zq by 3, right?
yes, sir.
Okay. Placing the limit, bring back to what is z. Z is cos theta. So minus of cos theta plus of cos q theta by 3. Placing the limits now. Tell me what we end up getting. Of cos theta and cos q, z is cos theta. So cos q theta by 3, we have to place limits now. 0 to pi. 0 to pi. First one will get us minus of cos 0 minus plus of cos pi. So minus 2, correct?
No, so you're getting plus 2, right?
First one will get us minus 2, right?
So we are integrated from 0 to pi, right?
Yeah.
So the first one should be 1 minus 1 by 3 then. So like, so if you add both of them together, you should get 2 minus 2 by 3.
Altogether, what we are getting totality? Please tell me.
Pi squared of 4 sigma omega 2 minus 2 by 3. Well, if you do simplify that, you get 6 minus 2 by 3, you get 4 by 3.
Omega, and what we are getting for sine q theta integration?
4 by 3.
4 by 3. 4 by 3. Okay. Shall we bring in the form of Angular momentum.
Yes, sir.
Okay. For a shell, what is moment of inertia known to us? For a shell, moment of inertia is 2 by 3 mr square, right? One of its axis, one of its diameter, 2 by 3 mr square. This multiplied with omega, right dear?
Yes, sir.
This is L for me, angular momentum. I want to bring that point over there. So pi square I'm keeping as it is R4. Could you help me with sigma? Sigma is charge, right? Divided by surface area. For sphere, that being 4 pi r square, right?
So what expression are you writing right now?
Omega, I'm writing in terms of Q.
So what does that
This
mean?
one. This one.
Yes, sir. Oh, you're rewriting the same expression. All right.
Pi square R4 sigma is Q
Mm-hmm.
by 4 pi r square.
Yes, sir.
Omega 4 by 3. Okay, dear?
Yes, sir.
Okay, pi gone, 1 pi gone. Only 1 pi is with us, is it?
Yes, sir.
Okay.
So,
1 pi gone. Okay. What else? 4 can also be struck. Tell me what do we get? Pi r square q omega by 3. Pi r square q omega by 3. Yes. This is what we are getting.
yes, sir.
Okay. And in terms of L, what can we write it down? Please tell me. Can you multiply and divide by 2 to incorporate L?
Yes, sir.
Also, I want, correct? Multiply it with 2m and divide with 2m. Fine? 2 by 3m r square is L for me, correct?
Yes, sir. So you
2
get
by 3m
pi q omega by 2 on the left.
r square is L for me, right?
Yes, sir.
What else? Divided by, tell me, how much?
So you've crossed the confines of the camera.
Okay, we'll tilt it a bit. Not tilt it, we have to change the arrangement to right. Is it fine?
Yes, sir.
Okay. Tell me what do we get then from here? In terms of L, that is what I seek. That's it. Nothing much. Wanted to bring in the point. So I seek in terms of L what we'll be getting. 2 by 3 mr square we got already. Q m. Can we write m over here? 2m.
Yes, sir.
So L by 2m. The only contention that I am over here to see is this term pi r square. Please check what are we getting and from here what do we get? Just what is this get me in terms of current, in terms of mu? Also, you may tell. Just note it down. Whatever we have gotten, note that down. Pi square r is power 4, sigma omega 4 by 3. This is what we are getting as mu. This is mu to us, correct?
Yes, sir. So you would be getting something like L by 2m times q pi, right?
Write that down. Take the calculation, please. There are a few corrections we made. Eventually, are all they all being incorporated or not?
So the magnetic moment is just the angular momentum scaled by a certain amount.
Yeah. But I need to first check the writings on board. Please do check. Sigma 2 pi r r d theta fine omega by 2 pi. Have I missed anywhere anything? If I have, remind me of it. Pi r squared. Pi r squared. I have carried an additional pi with me.
So have you?
No idea. Pi r squared. I squared entire. It should have been pi r squared.
Oh yeah, yes you have. Okay,
Okay, so
so in the final answer
pi
you'll
r
have another pi, so it'll just be QL by 2m.
pi will not be out here to be seen. That was the contention. Right, I carried a pi along. Additional pi. Right?
Yes, sir. Well,
You
wasn't it?
check?
Yes, sir. Yes, sir.
Check, check.
Yes, sir.
I
Yes.
carried a pi over here. Right?
Yes, sir.
Pi r square. Pi would have been out of it, the bracket. I put it inside it. So what do we get to the end? L by 2 pi. What else? Q into omega. Can we zero it now?
Yes, sir. What are you seeking?
We seek in terms of ln 2 pi. Ln 2 pi, ln 2m gone, right? Q omega remains, correct?
So omega doesn't. Omega gets, sucked up into the
Okay,
L.
what do we get over here? Q. Can you write Q?
Yes, so you just get QL by 2m.
QL by 2m, correct?
Yes, sir.
This is what we are getting mu to be. QL by 2. I was trying to relate this with dA by dt. Can you establish that relation now? Can we
dA by,
establish that relation now?
dA by dt is L by
dA by
2m.
dt is taken as L by 2m.
Yes, so mu is just aerial velocity times q.
We get a relation. If we get relation, good enough. If we don't get, we are to stick to this much.
Yes, sir, but what aerial velocity is under consideration here? In the original problem statement, there was just a sphere that was rotating, a charged sphere, perhaps.
U means to me area into current, yeah.
Mm-hmm.
Okay, so I'm taking it that ways, just to commit to memory. Else, this is the answer to the question which I did coin. Okay.
Yes, sir.
Okay. So shell we got in. After shell, what we have to do, we have to get back to our regular course, and the regular course being what will be magnetic field due to other structures. Before we get into early magnetic field due to other structure, what are the structures that we are to deal with? We have dealt with straight long conductor. We have dealt with ring. Next, we are to deal with shell. We are to deal with disk. We'll be going for them. Before of it, I seek this mu intervention in torque and energy calculation. We are coming from P cross E. We will check what is mu cross B to get me, what is mu dot B to get me. I repeat, mu cross B to get me, and what is mu dot B to get me. We'll be checking on those terms as well. But before of checking on any term, anything related to what on board, I need space, so I do ask. Check, please. There are a few tweaks that we went for. Anything which is not understandable over here?
Yes, sir, it's fine.
Is it okay, Shastam? Do check. I just to tell you what I was to seek and how if it is at all for you to remember as you are remembering two formulae in one shot. This is what being done over here, right? L dA by dt we know is equal to L by 2m. L by 2m over here, okay? And dq by dt is nothing but current. dq by dt is nothing but current. So current into area is to get me mu. From there, we were getting another form. That's it. Moving on to the next term. Write down. Find magnetic field generated. Find magnetic field generated by a ring of radius r at its center. By a ring of radius r at its center, in which current I is set. In which current I is set. What would be? Current I is set in it. Simple question. Can we get that? Current I, simple question, nothing much. We have solved it. You know what to place for x there. In the previous equation, what is x to be substituted known to you? Just place it out there and get another form. Generally, they do ask question on configuration which relates to this form. I'll be coming to those questions. I'll be asking you a few. So what will it be at the center? You know, on the axial point at a distance x, right? Yeah.
Yes, sir.
What is x to be substituted over there? For center to bring in notice. For center to bring in notice, we will substitute x by
r.
X.
So
There was x in the equation. R square plus x square raised to power 3 by 2. Right there.
Wait.
In the ring field calculation, what you got was mu naught 4 pi twice of mu divided by dq. And what is dq? dq is r square plus x square raised to power 3 by 2, correct?
Yes, sir.
Now, if I am to get to the center of it, what should be x replaced by? Simple question.
0.
0. And you get a form. That form is of import as few questions are based directly on that form. So let me bring in that form. Let me evoke that form. If it piques your interest, those questions are into coming. So let me first get to the form. What is that form? Mu naught 4 pi I by R into 2 pi. Read this way. Are we getting it this way? Mu naught 4 pi, not touch, virgin. I by R. I want to give in the form I by R because I want that angle term to be focused over here. What is the angle here? 2 pi. Why 2 pi? I have taken entire of the ring, so the angle is 2 pi. Fine.
Yes, sir.
If half of the ring taken, what will be the angle over there? Replace 2 pi by will be pi. Correct?
Yes, sir.
Okay. This is how it will change. Let me ask you, there is an arc which is subtending an angle 60 degree at its center. There's an arc subtending an angle 60 degree at its center. Find B field that will generate. Arc is carrying a current I. You can take it that way. Arc is carrying a current I. 60 degree, what field it will generate? What field it will generate? Tell me, the arc comes into center, it is suspending an angle. What I have taken the angle to be 60 degree. What current it is into carrying? I. What B field radius also known to you? What B field will it generate at its center? Yeah.
So you can substitute
You
pi
have to
by
go
3
by
into
the
this.
formula. Mu naught 4 pi I by R, and what should be the angle? 60 degree, is it?
Yes, sir.
No, no, not 60
Pi by
degree.
It's
pi
pi
by
by
three.
3
Pi by three.
equivalent. Oh wait, but there's an we can't also do that because what do you say? There will be a horizontal component in the plane also, right?
No.
That won't be cancelled as it was for the ring.
That was this one, dear. That was this one. It is not this one, it is this one.
So
So over here, B field will be in which direction?
so into the screen.
R, into the board, right?
Yes, sir. Oh,
That
okay,
B
okay,
field
fine. Okay, right, right,
into
sir.
that.
I got confused. Yes, sir.
Okay. Okay.
Yeah.
So B field will be this to us, and pi by 3 is what we have substituted over here. Fine. Question number 2, quickly, simple one. Over here, you have to calculate what will be B field. This is R1. Current, let's say, is flowing in this sense. Current is I. R1, R2. Please do it. Simple. There are, by the way, 4 components. Please be very careful about them. 1, 2, the arc, 3, the arc, 4. They are all to produce B field. If at all you are negating contribution of any segment, justify. And
So
logic are the same.
you would get mu naught by 4 pi, mu naught I by 4 pi 1 by R1 minus 1 by R2.
Very good. Mu naught 4 pi. I, of course, will be out. 1 by R1 minus 1 by R2. Seek the direction as well, please.
Okay, so the whatever segment is closer, that will dominate at the end. So it would be into the screen in this case.
It will be into the board, right? Okay. This is what we are getting for the case at hand. Tell me what came in IT directly taken from my road of 2016. Sorry, 2012. Directly from Iredove. This is what they got in Iredove. Closely fitted. Inner A, outer B. There are 10 turns. Find B field at the center. I is the current flowing through each turn. Find B field at the center. N turns are in all present. What will be B field? How will go about it?
So perhaps you can write the radius as a function of angle. Maybe if there are n turns, you could take the angle to go from 0 to 2 pi n.
Don't you think, Vasudev, that instead of writing it in terms of angle, will it be better for us to write in terms of thickness?
So thickness.
Yeah. Because B minus A portion is to encapsulate current.
Current ni.
Okay, B minus A will encapsulate current Ni.
Yes, sir.
So I think it would be incumbent on me to take a circle of certain radius and thickness, correct?
Yes, I suppose you could do that, but that would.
How will angle happen to me?
No, my idea was to express the radius lower boundary, which is in, the higher boundary, which is b, as a linear function of theta. So you go from 0 to n pi, and while you do that, the radius increases linearly from a to b. And then
0 to 2 pi, when you do, then the radius is not increasing. There are n turns, dear. Not in one rotation, it increases from 0 to 2 pi. If you are taking, you are referring only one rotation to it, correct?
no, I'm referring all the n rotations to n pi, 0 to 2n pi.
0 to 2n pi rotation, and you have to present it in terms of linear equation. Do it. Can be done. Yes. Can be done. But as it is repetition, I would even now prefer B minus A being known to me, current being known to me. So why not to go with a simpler version? The simpler version will be take the radius as a variable, small r, associate thickness with it, dr. What area you are to associate is pi r squared. I require B field, so I'll go by the formula which we have just now derived. Mu naught 4 pi, correct, intact. I by r, so r will be replaced by small r. 2 pi remains, correct. What will be I replaced by there? I will be replaced by current encapsulated by the ring of radius r, small r, correct? And
Yes.
what will that be? That is easy for us to negotiate. Tell me, what will it be?
So so the total current running through the entire circle is Ni.
Yeah, B minus A. Can we write it as B minus A, the thickness?
Yes, sir.
B minus A is to house what current? Ni.
Yes.
So dx length will house what current, or dr, whatever you are taking? Ni by B minus A into dr or dx, correct?
Yes, sir.
Now we can write dB. What will be dB as per what we have gotten? Mu naught 4 pi I, which is Ni dx by B minus A. Idea?
Yes, sir.
I by R. What is R over here? Small r. Right? Or x. I have taken x, so I'll stick to x. Fine?
Yes, sir.
And into what here? Into 2 pi, right?
Yes, sir.
Integrate it now, that's it.
So, but doesn't this, what do I say? Initially, the posed problem said it was a coil, so you would assume that the wires were, I mean, discrete. But you've taken that and made it into a disk. Doesn't that fundamentally
Closely
modify the
fitted.
problem?
It gets you closely fitted.
Oh, closely fitted. Must have missed that.
Yeah.
Okay, so if there were actually discrete wires, like
Write it
in,
down.
so if there were like discrete
No,
wires in,
closely fitted. Yeah, very closely fitted.
okay, if it is a spiral coil with considerable distance
This?
between the
Yeah.
coils, then what would it
Yeah. We can't go with this. Then we'll have to go by angle.
be?
We'll
Yes.
have to take angle. That's what you're suggesting. We have to take angle. But there also there will be some arguments made, eyebrows raised, some of them. And that'll be, how can you take it to be a circle?
You're not taking it to be a circle, you're just assuming it to have a certain radius at a certain point.
Then you get me the function. I'll get you a question. You want a question on it? There is y given to you, but there is a function also accorded, exponential function, or whatever function you want. It's gettable. As the spiral can be taken of any function by an individual, it is subjective. So to get E, how is R varying with theta? If that is gotten, sorted.
Yes.
Okay. Yeah.
Yes.
We take it for one more case. Find B field generated by this structure, infinitely long, bent in the form, making what angle? Alpha. Alpha by 2 over here, alpha by 2 over here, perpendicular bisector. These are semi-infinite or infinite, whatever you say. I want B field over here at this point. What distance? X, X from O. I want B field at P, P is at a distance X from O. Get me B field, please. It's an infinite wire bent at an angle alpha. You ought to find B field on a line which bisects the angle between the two. And it's what distance from the apex? It is or a junction. What is it from the junction? It is a distance x from the junction. OP is x. Find here.
0.
Who will it be?
Yeah.
How come?
So one wire creates, I mean, since it's lying on the angle bisector, you can say it is that the same perpendicular distance from both wires. So one
Yes,
wire.
dear. Zero. How come zero? That is what I'm asking. How come zero? I think I'm off the camera range. This is up. This also is up.
Oh, okay. All right, the same direction.
Be careful.
All right.
No confusion here.
Oh, so if they were going in the same direction, then it would cancel out.
Answer?
So 1 second. Okay. So would you say it is mu naught by 2 pi times I divided by x sine alpha by 2 whole times 2? So basically mu naught by pi times I by x sine alpha by 2.
Okay, Shaktam, where are you?
Yes, sir.
Shaktam? Yeah, what's the answer, Shaktam?
Mu naught I by 2 pi x multiplied by cot of alpha by 4.
Why is there a departure on answers? Check there.
Ooh, sorry, sir. I think he might be right on this one. But wait. No, I am right. I mean, my calculations are fine. Yeah, I mean, I stick with
Check
my
both
answer.
of you. There's only one answer is acceptable out here. What have we done, Vasudev? What are the angles that you are taking?
We know that the distance of the point from the point of intersection is x. So the distance of that from either wire should be x sine alpha by 2.
Okay.
So which is to mu naught by 2 pi times I by r. It's just I by r, that's the formula, right? Mu naught by 2 pi times I by r. So you just substitute r in there. That's it. And
What are the angles, dear, that it is subtending?
so
It's not infinite. It's not an infinite one.
Okay,
Yeah.
I forgot that.
Oh, you are indeed.
Yes, sir, fine.
Angle will be pi by 2. There will be
Pi by 2, another will be just
minus
alpha by 2.
pi by
Alpha
2
by 2.
minus pi by 2.
So y minus should be just alpha by 2, right?
That is
Oh,
not the
okay, okay.
angle
So
that.
yes, sir, yes, sir,
Ah,
sorry. My bad, my bad. Pi by 2 minus alpha by 2, yes.
okay.
Yes, sir.
Okay. You'll get from there. Nothing much. You must have missed that point.
Yeah.
Next, as you asked me that what if it is in a different form? What if it is not in the form of what we got in 2012 that was taken directly from my youth? So let us take a question. Let us say R is varying. Since you were in complex number the other day, Euler's form. Let me take R is equal to e raised power theta. How I taken write down? Carrying current I. R varies as theta with theta. R varies theta, or R varies with theta. R is equal to e raised power theta. R is equal to e raised power theta. So like this is the structure what you have to get. Ah. There. Okay. R is per theta. Okay, R is varying with theta.
Yes, sir.
Okay, and taken this form, let's say this way. Current, let's say this is current from here to here. Y, X. So the function is given.
So it's only from 0 to 2 pi.
R is equal to that. This is how it is in the plane, lying the plane, this is how it is oriented. What B field it will generate at the center? Can you calculate it? How will go about it? What is the B field generated at the center?
So you can write dB is equal to mu naught by 2 pi I by r of theta times d theta.
Okay.
So from I just
Get
integrate.
the answer to this? If you want the options, I can feed you the options. Do you want the options?
So I think we can do without that.
R is e raised to power theta. Define at the origin.
Is it mu naught by 4 pi times 1 minus 1 by e to the 2 pi?
By e to the power 2 pi.
2 pi.
Or 1 minus e to the power minus 2.
Mm-hmm.
That's what we're getting. This should be the regular course of operation here. The only requirement out there then will be function to be told. You are integrating in terms of theta, you ought to know how is R varying with theta. Right? Got the answer to your question?
Yes.
Any further? Okay, let's write next. A charge Q enters uniform magnetic field. Enters uniform magnetic field. Find equation for force. Find equation for force. Subsequently, deflection that it will undergo. Subsequently, deflection that it will undergo. As a precursor, take field generated by a solenoid. Take field generated by a solenoid to be the constant field. To be the constant field required for the actualization of charge movement. Required for the actualization of charge movement. So I'm stealthily moving from generation to effect. Are you getting it here?
So could you come
But
again from field generated? Missed a few words.
field generated by, what did I say? Remind me.
So what I've written, field generated by take field generated by solenoid to be the constant field required for. After that, I haven't written anything.
Required for the actualization of charges motion. Required for the actualization of charges motion. So what I'm trying to do over here, keeping the rhythm, trying to move from one portion of magnetic dispensation to the other. The first portion, as I've told you at the beginning, we began with the premise that first we had to deal with the generation. We saw for the generation vis-a-vis different configuration, but we have seen variation. If you check for what was the field that we were getting, it was varying, and the field was dependent on certain parameters. I'm referring to in this question a constant field. So first I am to get you a configuration to which you can relate constant field. Find here. The best way to execute it is to take a solenoid. A solenoid which is infinitely long. Now there are two versions or two understanding vis-a-vis infinitely long solenoid. One, it is an actual very long. Second, it is of significant length, but the radius is meager on calculation. Okay, certain length, defined length, significant length, but radius is insignificant. Or it is of significant radius, but actuality to get infinite length will be an impossible ask. So instead of going for infinite length, radius significant, what we do, radius is insignificant and length is finite. Find here? That's the analogy that we are drawing. Okay?
Yes,
We
sir.
mean by infinite long solenoid. This is what is meant by infinitely long solenoid. Not infinite, but radius bigger, very small, minimal on read.
Yes, sir.
Right? How do we get B field? How we will get B field? We'll make good of what we have studied earlier, which is what? Due to a ring. What was it? Mu naught 4 pi twice of mu by dq, correct? So what shall we do? Tell me. Can you advise me on? Can you make me go for easier depiction out here? What shall I do? For easier depiction, what I do, I take a certain length. I assume the radius to be very small, though it cannot be small, it will not be visible otherwise to you. So I've taken off significant length radius. What do I do next? I take a segment here, very small segment. Shall we take small segment? At what distance from the center? Let us say center, x distance from center and thickness is dx, fine?
Yes, sir.
What is current encapsulated by it? If the length is n per unit length, n per unit length. Find here, what is n over here? I take n per se as n per unit length, current per unit length. Okay, dear, what is n over here? Number of turns, write it down. N is number of turns per unit length. N is number of turns per unit length. So what will be current for length dx? N dx into I. Agreement? N is number of turn per unit length and each turn is to contain what current? I current. So what will be current for this segment? For this segment, current will be calculated as N dx into I.
Yes, sir.
What we generate over here can be gotten by mu naught 4 pi twice of mu. The twice of mu is nothing but current into area. Area is pi r square, where r is the radius of solenoid. Agreement?
Yes, sir.
Divided by, what do we write next? dq, which over here is r square plus x square raised to the power 3 by 2. Right there?
Yes, sir.
Can endorse?
So,
What?
so could you just write the general formula again? I think I've got that wrong.
Write it down. Mu naught 4 pi twice of mu by dq. dq is nothing but r square plus x square raised to the power 3 by 2.
Yes, sir.
And here, mu is I into area. I is this for the part that I have taken, n dxi. R square the area.
Yes, sir.
Okay. What do we do? Integrate it. Please do the needful. From where to where? Better to bring in the form of angle, correct? Always good because we have to go for infinite length. No point going to x. Where to bring in form of angle? So what do we write for angle incorporation? X is equal to r tan theta. Can we go by this?
So what's theta?
So from here, what will be theta? I have taken tan theta as x by r, correct?
Yes, sir. So,
X for me, this is r for me, right? Theta one.
yes, sir.
Oh. Is there needful now? Integrate, nothing much left. From where to where? What are the limits of theta that we have to place over here? Minus of pi by 2 to plus of pi by 2, correct? for infinitely long solenoid. Tell me what will be the B field, and is that B field qualifying for what we are to next take? A B field being constant.
So this is the B field at the very center of the solenoid.
It is infinitely long. There is no center to it.
Okay, so that's the B field everywhere.
The core, not outside. Outside will be zero.
So is that the B field only along the axial line or any other line that?
Any point in the core, it will be independent. That's why I'm just check it what you're getting from it. If it depends on R, if it depends on X, I have a different take. If it is independent, we'll say in the core, anywhere in the core, it will remain. Because there is no core as such, Vasudev.
So? Oh, it's like, I mean, by definition, it's like, I mean, radius is
Yeah,
small.
if it's actually infinitely long, it will be remain. You know very well that for that small region will remain. Outside will be zero. There'll be no B field outside.
Zero?
Justified. Why zero? Why zero? Let's say this is cross or dot, and this is cross, correct?
But so they're so close enough they'll negate each other's B fields.
Negate each other. So outside will be zero, inside will be reinforced. Draw and see for yourself, right? Dot means this way, right?
Yes.
Right.
Mm-hmm.
Cross means this way. Inside reinforcement, correct? Adding, yes or no?
Yes, sir.
Outside, opposite in direction.
But usually when diagrams are drawn,
Most,
magnetic field lines are drawn outside the solenoid, but does not inside
right?
solenoids. Something like that.
Right. We are assuming to be very small. So outside there will be no B field, and inside it is getting reinforced, correct?
Yes, so it would like, if it were small enough, it would like loop around the outside, go inside, and come outside again.
If it were, yeah. Then only it will be neutralized. Otherwise it will not be on.
Yes, sir.
What do we get from here? Not difficult. Come on, you're taking wrong side.
X is equal to 1
Dx will be r sec square theta d theta. Denominator you will get sine q theta, sec q theta. Here in terms of cos theta d theta will remain.
So basically, 2 cube theta dx x is taken as tan theta square theta d theta. Cos theta d theta, so cos theta d theta is
Right.
yes. So would you get 4 ni pi by r?
Well, are we there?
Yes, sir. It doesn't completely cancel out, does it? You get r squared in the numerator and r cubed in the denominator.
I'm slightly in odds with it.
Wait, I think I missed an r and the tan theta is going to expire.
Shaktam, why is the camera off? Shaktam, can you hear me?
Yes.
Shaktam, can you hear me?
Yes.
Why is the camera off?
Camera is on.
It is not on. Not getting you. Are you able to see him? Vasudev?
Yes, sir.
No, so I can't see him.
We can't see you. How is it on?
On.
Yes.
I can see it on my screen. It's on my.
You're not visible over here. How come it is on? Come over here.
Yes, so the same expression but without the r. 4 pi n I.
What is it? Mu naught?
Okay, the mu naught was taken as mu naught by 4 pi times 4 pi n I.
So mu naught ni.
Yes, sir.
B field is constant. Mu naught ni, right?
It does seem that way unless I've made some mistake. Which is probable.
I'm asking you to come. Aren't you listening to me? Where's the camera off? Yes. Come here. Where are you then? Well, here, why aren't you visible? Come here, come here. Situation. Come here. What is so big about it? You can come, you can be in the frame. Not an issue, come in. Oh, where is it? This is you, right? You're not visible? Why?
It's on, it's not coming on this. Yes.
So are we getting mu naught ni?
Yes, sir.
Okay. Fine. Now, the initiation of what we are going to next. What we are going to next to in initiation of it. What is it? Force. Force on a charge which is in movement. Force on a charge, point charge to begin with. So the heading should be articulated in the form force on a moving charge where it is made to move in a magnetic field. Down. Force on moving charge. Force on a moving charge.
Yes.
Okay, I'm not doing the detailing of where the magnetic field is, from where generated, is the magnetic field constant or not, is certainly an agenda. That is what I have made amply clear at the beginning of the class on this session, that magnetic field is constant to me. Magnetic field is not varying with time, not varying with space. Fine.
Yes.
Neither to vary with time nor with space. Magnetic field is constant. Need to know what force it will generate on a charge which is in movement. And what do we get the force to be? Force is product of, cross product of velocity and B field. That means force will always be perpendicular to both velocity and B field. Force will be perpendicular to both velocity and B field and is being marked as Q into V cross B. Okay? F is equal to what to us? F is equal to Q into V cross B. Perpendicular to velocity, perpendicular to B field, which makes it important do work. It is not qualified. B field is not qualified. It can definitely dissociate or deflect, but cannot execute work. Why? Because force will always be perpendicular to displacement. See for yourself, this is suggestive of force being perpendicular to velocity or being perpendicular to displacement. Thereby, work done by this field will be zero. It will not do work. It cannot do work.
Yes, sir.
Change in kinetic energy, if a charged particle is moving in B field, solo B field, there will be no change in kinetic energy. There will be change, there may be change rather in velocity, but there will be no change on speed. Seeing it?
Yes, sir.
Such a simple concept. ITJ asked you a question long back. ITG asked a question on a very simple concept, which is F is equal to Q into V cross V. And the questions goes as, write down. Conductor in shape of cuboid. Conductor in shape of cuboid. With rear face ABCD, with rear face ABCD and front EFGH. With rear face ABCD and front EFGH. Charge I, current I rather, not charge. Current I, correction. Current I is made to flow, right? Yeah. B field is through and through in which direction? This, that. Okay. Question being EFGH will be at higher potential. And 2. ABCD will be at higher potential. Option 3 will be at same potential. Option 4, data insufficient.
So I say EFGH will be at a higher potential.
How do you get that?
So the flow of electrons is opposite to the flow of conventional current. So the electrons would be flowing left. That would mean the Lorentz force would push it towards ABCD.
Okay.
So that means the potential would, I mean, if the negative charge accumulates, that the potential.
If I take positive charge,
then the potential would increase, right?
So why are you discounting on positive charge?
So because more negative charge would accumulate there, right, as opposed to EFGH.
I take positive charge. Positive charge to move to the right.
Yes, sir.
So B cross B should be outwards.
So, but the positive charge cannot move, right? It's only the electrons that are moving.
That was the catch in this question. I'm glad you got it. For positive charge that we have to check. We have to check for the negative, the actual charge in motion. Electrons this way, B cross B into, and since the charge is negative, so force with the negative will be outwards. Accumulation will be seen on the face. Which face? EFG. Right. You missed one part, by the way, Vasudev.
Oh, I forgot to negate the sign again. Alright, fine. So ABCD will be high potential.
Okay. So ABCD, because electrons are moving this way, and charge on electron is negative. There is one more negative. That will make ABCD what potential?
Higher potential.
Okay. Nevertheless, the question which I did ask, back to it. This is what the situation is. Charge positive charge enters. This is of length. Tell me what will be deflection as it makes an exit. As the charge makes an exit, what will be deflection seen in the charge? By deflection, I mean angle between the line of exit and line of entrance.
So, what is the magnetic field in this region?
E into the board constant.
So there is certainly a
With
there is a possibility it can loop back and just come out the way it went in, right?
N, and subject to D. It'll be subject to D.
Yes, sir.
In that case, you will say deflection is of pi.
Yes, sir. So the maximum deflection possible is pi, right?
We get you the value of D in that case.
Yes, sir. So the maximum deflection possible is pi. It can't deflect it more than that.
Yes, yes. Okay. MV by 2 QB.
So if you equate the force to say a centripetal force, if you say QVB is equal to mv squared by r.
QVB will be force which will continuously keep on changing its direction, right?
Mm-hmm.
And if it is to loop, it'll loop only for a case when it is being projected at an angle 90 degree. 90 degree to B field. Otherwise, you'll get pitch helical path, helix. We'll come to that later. For now, I'm keeping the angle intact 90 degree. So it's to get a negotiation of circle. And if it's getting a negotiation of circle, then mv square by r, as you said, should be equated to qvb, getting you r equal to how much? mv by qb, correct?
Yes, sir.
R will be mv by qb, right? Yeah.
Yeah.
Okay. And it enters, it leaves.
So
What to do?
Okay. Okay, so you've said d is equal to mv by 2, so it can't loop back.
So it won't.
So it'll just 1 second. So if it is going this way,
Do you have anything to say?
so I've got it. I just don't know how to get that angle.
Shaktam, are you to say? Shaktam? And yeah, are you to say something to it? Some answer?
So theta can be equal to 30 degrees because sine theta is 1 by 2. We take d by r to be sine theta.
Okay.
And the deflection will be r minus r cos theta, which will be r into 1 minus cos theta in bracket. Cos theta will be cos of 30 sine of 60, which is root 3 by 2.
Deflection in terms of what? Angle you said already.
R minus r cos theta.
No, deflection in terms of angle or deflection in terms of length. Deflection in what terms are you expressing?
Angle is 30 and also in length it will be r into 1 minus cos theta. I was expressing both.
Okay, so angle is what we should in general represent because axis will keep on changing, right?
Yes, so theta is pi by 6.
Theta is equal to how much? Pi by?
630.
30 degrees. So that's what we're getting, and of course, it will depend on D. There are 4 or 5 questions in SC Verma with varying D values. Accordingly, you can calculate deflection. This was one case. In the second case, write down a particle is thrown. I'm just drawing for the case, don't write. See, there's a B field. I'm throwing a particle this way. And from the same point, I'm throwing particle this way. Okay. Mass is M, speed is V, mass is M, speed is 2V. B field through and through present into the board. Right?
Yes, sir.
What are we to calculate? Or what are the options? Write the option directly.
So what do we need to get?
The options. Option will let you know what you have to get. Line joining centers. The line joining centers of respective circles is perpendicular to initial direction of velocity. Is perpendicular to initial direction of velocity. Option number 2. They will meet after regular interval of time. They will meet after regular interval of time. Option 3. They will negotiate circle of same radius. Option 4. Line joining their centers make 0 degree with the line housing initial velocities. Okay. They are positive charges. Mass m thrown with speed v and 2v respectively in opposite direction. Just to remind you, I'll come back with Ampere's law. The next class. Ampere's law will let you know another way for symmetric case, another way to get B field.
So option A and B seem true.
Is they will be negotiating circle
No, line
with
joining
the
this line
point
joining the
making what
centers of the respective circles is perpendicular to the initial direction of velocity.
that is correct,
And
and
they will also meet after regular intervals of time, meaning both of them have the same omega.
okay, absolutely correct. That's the case. The first two options are right. The other two are hogwash. Now, to culminate this class, find deflection. Find deflection for the two cases shown. Find deflection for the two cases shown. Case number one is this here. There's a circle with the presence of B field. Charge enters Q, V, and over here, this can go to the center. Whether it will go or not, that's for you to decide. And what is being shown, by the way, is what I have to draw. It comes out as shown. Find the angle of deflection. Sivama. Find the angle of deflection. What you have to find is this angle, alpha. Alpha will be the angle of deflection, right? Or pi minus alpha, what will it be? Pi minus alpha. Okay?
Yes.
It was going this way. Right? So what is the angle? Pi minus alpha. Anyway, alpha got in, pi minus alpha is deemed to. Get me, what will it be then? How will you go about it? What is the deflection? 1. 2. The alpha B field will form in this segment, only below the line. Below the line subtending alpha with x-axis is seen B field present and is uniform. A charge enters this way, QV. What will be deflection in this case as the charge makes an exit?
So would it be well 90 degrees? The second one.
This case.
The second,
Second one.
Yes.
Maybe I'll check that.
I mean, is that line y is equal to x?
No, that is not y is equal to x. Alpha is not 45 degrees.
Oh, okay. So there's alpha. Fine. Then that won't be the case.
Two cases on board. One taking from a Harvard book, which is also to be seen in packages nowadays. The other one, of course, is from S.A. Varma. Have any answer? Mass is also given to us. Is the mass? Have any answer? Sakta, unmute yourself.
This will calculate.
Okay. Second one generally confounds students.
So can you say tan alpha by 2 is equal to mv by qbr? So alpha by 2 is equal to tan inverse mv by qbr. 2 tan inverse mv by qbr
Okay.
for the first one.
How do we solve this? As you may have done rightly so, you have completed a circle, right?
Yes, sir.
Circle of what radius? MB by QB. So if I am to draw 90-degree, because this also is tangent, if I am to draw 90-degree, they are also tangent. Then these are what to us? MB by QB.
Yes, sir.
Yeah, this is MB by QB. This is R. You can get easily what would be tan of the angle alpha, right?
Yes, sir.
From the visible. Second one. Something to Flomox. While said Flomoxes, generally do divide it into two parts. We take a long line and the other they will take perpendicular.
So,
It Flomoxes student why? Because they generally divide this V in two parts. One they will take this way, the other they will take perpendicular. Nothing much over here. Much ado about nothing, dear. Assume it to be circle. Till the time it is inside, it will follow a circular path, right?
yes, sir.
From there you can get it. Assume it to be through and through present. And then what will it do from here? It will move in a circle, right? I've
Yes,
been
sir.
through and through present. You have negotiated a circle, right?
So you just take a section of that circle.
Take a section of the circle and from there you'll be getting. Fine?
Yes, sir.
Okay, that's it for the day. Meet you the next day. Your maths class will be arranged either today or let's say when. We was calling, I couldn't take the call as I was in class. I'll make you aware of it, and I'm also trying to get you into a batch which is being run by school, as I've told you earlier as well. And that batch will exist for another month. So if certainly will be possible, made possible, then you'll have to take classes at 7:30 in the evening. And 7:30, I think, is amicable for you, right?
Yes, sir.
Okay. Thank you, dear.
Thank you, sir.